Hi, I'm here with Erik Vogt to talk about a subject that's top of mind for many in the localization industry, and that is AI LQA. Now, Erik, for those who are just exploring this topic, can you give a brief explanation of what we mean when we say AI LQA?
Sure. I think there's a broad group of categories here. So there's things like quality estimation, there's things that identify where quality issues might happen. And there's lots of different ways of approaching this. And so under the hood, there's lots of internal capabilities that are involved here. So whenever, for example, when you use a tool like Grammarly, when you're typing in English, that is essentially doing a QA for you. Or there's also lots of products that are built in that help where the commas go and where you should check your spelling. Things like that are kind of built into the authoring environment, just like they're built into the translation environment. So there's some of this, it's sort of implicit. And a lot of the TMS tools out there and CAT tools are designed to incorporate some of these QA capabilities in it. But I think we're talking about something else, which is can you use it after that process is done? Is there a tool that can then take another look and find where there might be some issues? And this can be especially helpful when doing updates on large projects where you don't really have the budget to review everything. You want to use a tool that will find issues more efficiently for you and just help you find where those things are. So there's QE capabilities is really like how likely is this the right number? It attaches a score
Mhm.
to it or a category to it, like red flag, not red flag. And this category of products, and there are several very strong ones on the market, have several different particular use cases. And one is to get an overall assessment. Like, how is this overall? What is our general guess as to whether or not this is a go, no go the way it is? Another one is to, if you have a limited budget, can you not review, for example, things that are likely good segments? Like, or can we eliminate those? And some of the case studies out there are showing you could eliminate 30, 40% of the content for review, maybe more,
Or-
if it's scoring above a certain amount. That cuts that much out of your human labor, and that can be a very powerful motivator. On the flip side, you could also say, no, just show me the bad ones because I want to take a finite capacity and I want to focus my human attention on the most likely worst stuff that's out there. So each of these kind of ways of thinking about the value proposition in these tools is a way of helping either focus on cost reductions as a this is safe or focus on best use of human attention on what is worst. Now, here's the interesting part. What if you have a capability that can detect what's wrong, why not just have it fix everything? Just have it just do it all together. Now, therein lies where things start getting a little interesting because as we think about the capabilities of a QA system, what's your bench line? What are you comparing against? Generally, you're comparing to a human. Now let's look at human variability.
Okay.
If you send LQA to different reviewers using the exact same instructions and rules, we see that there's generally about a zero point 0.6 uh, correlation between the output of all these using an MQM methodology. That's a number that I've heard mentioned from multiple sources as I think it's probably truish that generally speaking, there's about that kind of correlation.
Mm.
What is the difference? It is often in what the reviewer finds. So really good reviewers, and I've done tests myself where I've tried to find the errors. And generally speaking, you can give people tests and say, well, you know how many errors there are in here. You do a standard LQA, they'll find most of them, but different reviewers will miss different of them. In other cases, they might classify them a little differently, put them in different categories. Is it terminology or is it accuracy? Or in other cases, there's a difference of opinion about severity. But anyway, there's a certain preferential dimension. There's a certain kind of thoroughness dimension. AI has a couple advantages. It's pretty consistent and it doesn't get tired and it's going to find what it's going to find pretty fast. So it can be a powerful tool to help accelerate the human LQA process also, which
Mhm.
is a cool way to think about it. Now, AI is not as good as that when you think about the typical correlation between an LQA automated AI LQA and correlating it with what, the human standard is about a point 0.4. So it's not as, it's good, but it's going to facilitate, but not replace humans. And we can have a debate about whether it's going to get to 0.6 next year or ever, but that's kind of where things are right now. So anyway, just to finish that thought, the quality target here is often to try to get up to an equivalent of a human or better. And that's often a function of the amount of data that the model has that you're doing that LQA with. And sometimes that needs to be equal to or greater than the amount of data that the MT or other tools had to start with. So it's a lot more metadata, it's a lot more training. It's the same story we've worked on years to try to figure out how to make MT the best. It also needs a lot more data to be better than the MT that it's or the humans that it's trying to judge. So I think some tools out there take an approach of let's make this tool available in the LQA environment and help facilitate the human review. And then you end up with the classic human plus AI is better than the alternative. But as I mentioned, there's other use cases in there to consider as well. So that gives you a little bit of an idea of the big picture for the whole QE and LQA capabilities.
Yeah. So maybe we already covered this, but what is the state of the research now? Like, how good is it? Is this something that, people who want to test it out can kind of do and expect a reasonably good result, or are they still vast fluctuations in how things are coming out in the end?
Some of the tests we've done have been incredibly encouraging. Like some of them we were getting up to catching 90 to 99% of the issues, like very, very positive, especially for very good starting point. The AI is capable of doing some really, really cool things. And again, this is provided with the correct glossary, the correct guidance. It's theoretically possible. That having been said, there's other things to think about, like the level of false positives, like how it might find all the issues, but how many false positives are, and what's the effective effort at clearing all those false positives that the AI thinks could be issues that aren't. There's other issues such as the variations between languages. I think East Asian languages pretty reliably are harder to meet the same standards compared to the Western European languages, which were linguistically more similar, and also there's a ton more data, so it tends to be more effective. So I think we run pilots that take about a week to kind of do all the setup and effective review. I think if other systems may be able to do pilots in different amounts of times, depending on kind of what their approach is. Some of them are out of the box, are ready to test sort of the generic version right out of the box. Like I think some tools out there, I think Taos provides sort of a model with estimates that's pretty much ready to go. And there's ways of improving it, with the appropriate training and instructions.
So it sounds like there's still some limitations right now on what you would even recommend someone to use this for. Are there any limitations that we haven't covered that you would kind of warn people against? I know we talked about like the language will make a big difference if it's Japanese or English, things like that. But is there any other kind of outlying factors that people should be aware of?
But one thing we recognize is that models do have things that make them make mistakes. Like we think
Yeah.
about it as hallucinating or just errors. Having worked with this a lot, it is hard not to personify these models a little bit. 'Cause I think of them as kind of children in some ways. I'm finding it fascinating that I'll give the same instructions to the AI sometimes multiple times and it will come up with different, even fundamental ways of responding. It's almost like experimenting to see what's going to make me happy. So what's fundamentally and critical is to break down the problem into chunks. So we think about it, people use the word agentic, but we also are thinking about it in terms of a tasking AI to do narrow specific things one at a time, and you put that in sequence, and then you're going to get to a better result. So it's not a nebulous like brain like humans. Ours is one, you can't unpack our brains and have individual sub processes work on it, but we can work on one part of the problem at a time. We can break down a problem and do one thing at a time. So you might focus on glossary first, then you might look at style, then you might look at something else. And so we can put a number of different sort of tasks or agents together to string them together to produce the desired outcome. The second thing I'll just say is that tuning is critical, and tuning manifests in different ways, both from input instructions to the prompts themselves. So we have a kind of a dynamic prompt mindset. So we automatically have the AI create the prompts that it uses, kind of based on the content that it's evaluating. But I think it's really critical to see how that works and then revise and cycle through some iterations there to make sure that you're getting the most from that output. I guess to answer your question as succinctly as I can, much more succinctly, is be careful of turnkey solutions out of the box. Just no effort involved. It's just going to do its thing. It's probably going to be less than what you could do if you provided more appropriate support and fine tuning to ensure that you're getting the best possible outcome for at this exact time.
Okay. So, what do you see, or what do you think we will see happening in the near future with this technology?
Well, it's going to keep getting incrementally better. I think the operators will get better at deploying these capabilities in more efficient and effective ways. I think the efficiency is one thing that factors more at scale. So think about the compute load for each of these tasks. How efficiently is the prompt transacting the instructions that you're trying to get to? There is a cost associated with it. There's time associated with it. And I think we're seeing a faster throughput. Another thing I'd just say too is I would expect in the way we think about these things that the tech and AI costs may start showing up in proposals as we start thinking about like the cost of these. It's still relatively minor compared to the human cost. So just often it's kind of loaded in there and included in the weighted word. But I think when you start moving at orders of magnitude higher scale, then it starts to become more of an issue. That's one. Second big trend, I'd say the models, the foundation models that most of our capabilities are built on top of are themselves evolving. And I think I'm loving the increased interest in quantifying the relative value of each of these. I think, for example, there's Intento does their state of AI report that compares just at a high level. It's very kind of general, just to give you an idea of the relative strengths of different machine translation models. I imagine we'll start seeing more comparative, generic sorts of analysis out there that would show us the relative strength of the different foundation models. But really, these are just entry points. They're just a beginning of the conversation. Any given customer's target is a unique situation, and it does require a very careful consideration of the prompt optimization, the optimization of compute, the optimization of which number of steps kind of yields the best possible outcome. So these are all iterative and in some ways a little trial and error, but in general, we're seeing you're getting to the right answer faster. That's the trend that we're seeing. Yeah.
Okay. Well, great. Well, thank you, Erik. I think this has given a really good overview of kind of where we are right at this moment and what we should be keeping an eye on as things develop into the future. So thank you so much. Any last things you want to add?
This is a really exciting time to be in this industry. It's really cool. I think that we're seeing more and more interested in this ourselves. Like I said, some of the pilots and some of the experiments are startlingly good. At other times, there's surprising mistakes. So it's it's an evolving story here, but it's a fun time to kind of be exploring this as we learn a new language around this different approach to how we use AI to get the best possible outcome. There's no guaranteed magic bullet yet, but but anybody who isn't using these tools is leaving a considerable amount of potential on the table.
Yeah. Yeah. All right. Thank you so much.
Sure. Thank you. Talk soon, Steph.